In this video, we are going to revise some questions from Science Paper 2, Chemistry of 2016 for external. Now, in this video, we'll just focus on the first section, section A. Now, let's look at the first question. All matter is made up of small particles, which are referred to as the basic units of matter. The small particles of matter are always in a random motion. The first question, state any two basic units of matter. Now, do not confuse the basic units of matter to states of matter. So the states of matter, we have the liquid, solid, and the gas. So these are the states of matter. Now, for the basic units of matter, we have the atoms, then ions, and the molecules. Now, even if the question is asking us to give the two, I've just written the all three basic units of matter, since this is just a revision. But whenever you're dealing with a question like this one, on a final exam, you can just choose any two of your choice. Now let's move on to question B. Suggest two pieces of evidence which show that matter is made up of tiny, randomly moving particles. So the best two evidence we can use are the processes. So let's use the first one. Diffusion can also be used to show that matter consists of tiny particles. Then the second process, Brownian motion. So all these are two processes that I've listed here requires with the movement of particles. So therefore, they can be used to show the evidence. Now let's move on to question C. The diagram below represents one of the physical states of matter. Name this physical state of matter and explain why it has a fixed volume. So whenever you are trying to give the name to a given state of matter, you just have to look at the arrangement of particles. So the arrangement of particles here, we can see that the particles are closely packed. So therefore, we are dealing with a solid. Then for the explanation that we can give here is the particles are closely packed. The particles are closely packed. The particles okay, so this is the reason why a solid has a fixed volume. So therefore, the particles are closely packed, and therefore it's hard to change this shape, including the volume. Now let's move on to question 2. Each of the following statements is incorrect, but if one scientific term is replaced by underlined by a correct one, the statement then becomes true. Identify the wrong word term, underline it, and in the space provided, write the correct word. So we have been given some sentences where one word is incorrectly used. So let's look at the first question. So the first question is condensation is the change of state of matter from solid to liquid. No, condensation, this is the change from gas to liquid. So here, the best one, we are dealing with melting. So melting is the change of state of matter from solid into a liquid. Then let's look at question B. The basic units of matter that exist in sodium chloride are molecules. So no, molecules consist of non-metals only, but for sodium chloride, sodium is a metal, chloride, which is chlorine, is a non-metal. So here we are dealing with the ions. So the basic units of matter that exist in sodium chloride are ions. So ions comes as the result of a compound that consists of a metal and a non-metal. Now let's move on to question C. Isotopes are compound with the same molecular formula but different structural formula. No. Isotope, we are dealing with a compound of the same mass number but different atomic number. I mean of the same atomic number but different mass number. So this one is isomer. So here we are dealing with isomers. So isomers are compound with the same molecular formula but different structural formula. Question D. Calcium hydroxide is classified as an amphoteric substance because it dissolves in sodium hydroxide solution. Calcium hydroxide is not an amphoteric oxide. An amphoteric oxide is zinc oxide. An amphoteric oxide is a substance that can behave as an acid at the same time it can behave as a base. Then for the question E, zinc and chlorine bond covalently. No. Zinc is a metal, chlorine is a non-metal. So here we are dealing with the ionic or ionically. So these are the answers for question 2. Now let's move on to question 3. So two elements A and D are represented by the notation shown below. So we have this A with a mass number of 23 and atomic number of 11. Then another element D, mass number 16, atomic number 8. Part A, draw electron shell diagram to show the arrangement of electrons in the atoms of A and D. So let's look at the first. Let's look at the electronic configuration for A. So we can see that we have 11 electrons. The first shell will occupy 2 electrons. Then if we subtract 2 from 11, we have 9. The second shell will occupy 8 electrons. Then the outermost shell, which is our third shell, will occupy 1 electron. So this is how our A will be. So we have A. So the first shell we have 2 electrons, then the second we have 8, then the last outermost shell we will have 1 electron. So let's look at D. So D has 8 electrons. You know that the first shell occupies or is filled with 2 electrons. So if we subtract 2 from 8, the second shell will have 8 electrons. Okay, so now let's indicate the first 2 electrons here. So the outermost shell for this element D will have 60 electrons. So we are done with the question A. Now let's look at question B. When atoms of element A and atoms of element D react together, what type of bonding occurs? So let's look at the element A. So element A is a metal because it has 1 electron in its outermost shell. So the best way you can identify an element, whether it's a metal or non-metal, in a question like this one, you just have to look at the number of electrons in the outermost shell. So if it has 1 electron or 2 electrons up to 3 electrons, therefore that is a metal. then 4 and above it's a non-metal. So A is a metal, then our D is a non-metal. So the type of bonding that occurs between a metal and a non-metal is ionic bonding, because there is the transfer of electrons from the metal to a non-metal. Now, Roman number 2, when atoms of element A, using the dot and cross diagrams, show the structure of the compound formed between A and D, showing all the electron shells. So now let's draw this dot and cross diagram. So let's look at the chemical formula for this compound. So we have A with the valence of 1, since it has 1 electron in its outermost shell. D has 6 electrons in the outermost shell, so it needs 2 more electrons, so it has a valence of 2. So if we use the crisscross method, we are going to see that we have A2D. So meaning we need 2 atoms of A to contribute the 2 electrons that are needed by D. So what this means is the ratio is a 2 to 1. 1 atom of A cannot satisfy 1 atom of D, since the D needs 2 electrons to be satisfied, while A just needs to lose 1 electron to be satisfied. So A should invite another atom so that they are able to now satisfy the D. So let's have this picture. So we'll begin with A. Then we have another A. Okay, now so the first shell 2 electrons, the second one 8, then the outermost shell 1. With this one we have the same. Now let's look at the atom for D. So there will be, so this A will transfer 1 here, even this one will transfer this one. So now we can have now this, our A. So we will ignore the outermost shell since it has lost. So each atom of A is now stable. Now for D is also stable. So now this is our final answer. Then we will put a -2 here, indicating that the D has gained 2 more electrons. Then we'll put a +2 here, indicating the 2 electrons that were lost by the 2 atoms of A. Now let's move on to question C. State any 2 physical properties of the compound formed between A and D. So the compound is ionic compound. So number 1, it conducts electricity. When in molten state. Then the other one, it has high melting and boiling point. So these are 2 physical properties that we can state. Now let's move on to question 4. When carbon dioxide gas is bubbled through aqueous calcium hydroxide, which is lime water, the following reaction occurs. So we have this reaction, calcium hydroxide plus carbon dioxide, giving us calcium carbonate and water. Now the first question is write a word equation. So here we have been given a chemical equation. So our duty is now to write this one into a word equation. So the first one will say calcium hydroxide plus carbon dioxide will give us calcium carbonate plus water. So this is our word equation. Now for question B, if 1.2 cubic decimeter of carbon dioxide gas measured at a room temperature and pressure was bubbled through excess calcium hydroxide solution, calculate the Roman number 1 mass of calcium hydroxide solution which is reacted. So for us to calculate the mass, so mass can be found by multiplying number of moles with the molar mass. So from the formula we need to first, we can look at the molar mass. So let's look at the molar mass for the molar mass for calcium hydroxide. So calcium is C times, there is only 1 atom, plus, then for hydroxide, let me just answer it here. Okay, so calcium hydroxide, so there is 1 atom of calcium, so calcium times 1 plus, so the number, this subscript here should multiply everything inside the bracket. So we are going to have oxygen times 2 plus hydrogen multiplied by 2. The mass number for calcium is 40 times 1 plus 16 times 2 plus 1 times 2. So 40 times 1 is 40 plus 16 times 2, 32 plus 2. So 40 plus 32 is 72 plus 2, 74. So 74 is our molar mass. So 74 grams per mole. Okay, so we have now calculated the molar mass, so we just have to find now the number of moles. So let's find the number of moles for calcium hydroxide. Now, since we have been given the volume of carbon dioxide, we can use this volume to find the number of moles of carbon dioxide. Then we are going to use a mole to mole relationship to find the number of moles of calcium. So what this means is, number of moles is equal to volume over molar volume. So number of moles is equal to, so the volume is given 1.2 divided by, now molar volume depends the condition, so you have been given RTP. So RTP is 24. So if we divide the 1.2 divided by 24, we're going to get 0.05. So 0.05 is the number of moles for carbon dioxide. Okay, now let's look at let's go back to our chemical equation. So we can see that there is 1 in front of calcium hydroxide. There is also 1 in front of carbon dioxide. So since these two substances has the same mole ratio, even the number of moles will be equal. So 0.05 moles of carbon dioxide is equal to 0.05 moles of calcium hydroxide, since they have the same mole ratio. So we can now proceed with our final answer. So our final answer is now mass is equal to 0.05 times 74 grams per mole. So if you punch this on a calculator, you should get a value about 3.7 grams. So this was the mass of calcium hydroxide. So the data given in the question will help you to determine the formula to be used for you to calculate according to the need of the question. So now let's move on to Roman number 2, mass of calcium carbonate. So mass of calcium carbonate. So we're saying mass is equal to number of moles times molar mass. So calcium carbonate, let's look at the mixture for calcium carbonate. So from calcium carbonate, you can see that there is 1 atom of calcium plus 1 atom of carbon plus 1 atom of oxygen. So the mass number for calcium is 40 times 1, 40, plus carbon is 12. Carbon is 12, plus we have 3 atoms of oxygen times 3, 48. So the reactive formula mass for calcium carbonate is 100. So therefore the molar mass is 100 grams per mole. Now let's look at, we need to find the number of moles. So let's go back to our equation. So we can also see that there is 1 in front of calcium carbonate. So since these three have the same mole ratio, the number of moles will also equal to each. So the same 0.05 is equal to this calcium carbonate, since it also has 1 as a mole ratio. So number of moles, we use 0.05 times 100. So if we multiply this, we are going to get 5 grams, because 0.05 times 100, we just move the decimal to the right 2 times. Now let's move on to Roman number 3. Describe what will be seen as the carbon dioxide gas is bubbled through aqueous calcium hydroxide. So a white PPT. A white PPT will be seen. So it is going to turn into a white cloudy. Okay, so now let's move on. Okay, so now we can move on to question 5. The following table shows some information about the second member in the respective homologous series. Complete the table by filling in the correct information. So we have a table that consists of 3 columns. So the first column requires the names of the homologous series, the second one name of the member, the third one structure. So the first row here has alkenes. So the second member of alkenes is ethene. So whenever you see F means 2. Then the structure will be alkenes. The one with the E has double bond. Okay, so now then also for the chemical formula for ethene is C2H4. So let's go to the second row. So ethanol. So the family or the homologous series is alkanol. So these are alcohols. So we have alkanol. The structure. So this is our structure. The space is too small. Okay, or maybe let me write it here. So this is the structure for ethanol. Display the structural formula. Then the chemical formula is C2H5OH. Okay, now let's move on to row number 3. So from there we can see that we have 2 carbons. Then we have this part here, a COOH. So this shows us that we are dealing with an acid. So this is ethanoic acid. Then the name of the homologous series is alkanoics or carboxylic acids. Okay, so let's move on to question 6. The diagram below shows part of the periodic table. We have been given this periodic table with some of these elements. Now state the name of an element from this part of the periodic table, which the first one forms univalent cations. So univalent, it means in terms of cations, it means an element that has the ability to lose only 1 electron. So those that loses 1 electrons are known as univalent. 2 electrons bivalent. 3 electrons are known as trivalent. So univalent, we are looking at 1. So the elements with abilities to lose 1 electron come from the first group of the periodic table, group 1. So we can just say lithium, since it's a name. Then reacts mostly vigorously with cold water. So the most reactive elements on the periodic table are those from group 1, but the one that is the very reactive is potassium K, because as we go down the group, in group 1 the reactivity series increases. So we have potassium here. Then forms the formula monoxide and this one, there is 2 when X, so this is nitrogen. So we have nitrogen monoxide and also dinitrogen oxide. So whenever you see a 2 here, it's dinitrogen, since we have 2 atoms of nitrogen. Then does not react with oxygen. So we can just get helium. Group 80 does not react with anything. Now let's move on to question 7. Solutions of hydrochloric acid and sodium hydroxide are mixed together and they react as shown. So here, this is a base. Then we have an acid here. So we are looking at the reaction between a base and an acid. Now let's look at the first question. Write a balanced chemical equation. So sodium hydroxide, the chemical symbol is NaOH. The state is aqueous. Then for hydrochloric acid, HCl, aqueous also. Then for sodium chloride is NaCl, aqueous, plus H2O. So for a reaction like this one, it's a balanced one, since the reactants have the same valence number. They have 1. Sodium has a valence of 1, hydroxide has a valence of 1, hydrogen has a valence of 1, chlorine has a valence of 1. So this one will give us a balanced equation. Now let's look at the question B. State the name for this type of reaction and write an ionic equation for it. So type of reaction, the reaction between base and acid, and we can see that the base is strong and an acid is also strong. So we are looking at the reaction between a strong base and a strong acid. So this is a neutralization. Now for ionic equation, so we just write the whole ionic equation. We not cancel because we are not asked to find the net ionic equation. So let me break it here. So sodium aqueous has the charge of +1, hydroxide charge of minus aqueous, plus C, hydrogen plus aqueous, then sodium, sorry, forgotten chloride. Okay, so plus C, chloride, then sodium plus aqueous plus chloride aqueous plus H2O liquid. So you only break those in aqueous phase. So this is our overall general ionic equation, but if we are looking for net ionic equation, the total one, we'll consider this will have, we need to do, we cancel sodium here because these are spectator ions. So our net equation will have hydroxide minus aqueous plus hydrogen. So this is now our net ionic equation. So it depends with the need of the question. So now let's move on to question C. Describe how crystals of sodium chloride can be obtained from the solution formed during the reaction. So since this product consists of water and the sodium chloride. So for us to remain with the sodium chloride as crystals, first we need to heat the solution until some water evaporates. So heat the solution. So until water evaporates. Then number 2, cool. So we can say allow the solution to cool. Allow the solution to cool. Then for the third one, so after it cools, then it will start to harden. It will start to harden and form crystals. Okay, now let's move on to the last question. So when hot magnesium metal is introduced in a gas jar containing carbon dioxide gas, the carbon dioxide is decomposed and the following reaction occurs. So we have magnesium react with carbon dioxide, giving us magnesium oxide and carbon. Then in this reaction, both oxidation and reduction occur. So question A, what name is given to describe a reaction in which both reduction and oxidation occur? So this is known as redox reaction. So redox reaction is a reaction in which reduction and oxidation occurs at the same time. So it's a simultaneous kind of a chemical reaction. Then state with reason which substance is oxidized and which substance is reduced. So substance oxidized, magnesium. So magnesium has been oxidized from magnesium metal to magnesium oxide. So reason, it has gained oxygen. So we can see on the left side the magnesium has no oxygen, while on the right side the magnesium has the oxygen. So it has gained, so this means it has been oxidized. So an element that gains after a reaction, if it gains or if it combines with oxygen, therefore it is oxidized. Or maybe the picture that we can see, for us to have magnesium oxide, we'll see that oxygen is a non-metal, so the magnesium will lose the 2 electrons, will give the 2 electrons to the oxygen to become stable. So whenever there is a loss of electron, we can now say that magnesium has been oxidized since it lost some electrons to an atom of oxygen. Then substance reduced, carbon dioxide. So carbon dioxide has been reduced because it lost oxygen. So you can see on the left side carbon dioxide, there is oxygen there, but after the reaction carbon has remained alone, so it lost oxygen. Then which substance is the reducing agent? So for you to identify the substance that is a reducing agent, you just have to look at the substance that was oxidized in the process is a reducing agent. So in our case, magnesium is our reducing agent since it was oxidized in the process. Then classify the two types of oxide from the equation above. So magnesium oxide is a basic oxide, since there is a metal and a non-metal, so basic oxide. Then carbon dioxide is an acidic oxide because they can dissolve in water to give us rain. So that's it for this video. Thanks for watching.